Good morning, 11th standard students. Good morning.
Morning, sir.
Morning,
Good
sir.
morning, sir.
Morning, sir.
Okay.
Good morning, sir. Good morning, sir.
Okay. Good morning. Good morning.
Good morning, sir.
Good morning to all. Or good morning to everyone. Okay.
Good morning, sir.
Today, in this physics class, we will start the new chapter in physics, work, energy, and power. But in previous chapter, in laws of motion, apart from that of angle of repose and the applications of angle of repose, rest of the topics in laws of motion in our department decided to teach at the time of after reopening the schools. It is a right time to teach that kind of topics. For example, rolling friction, dynamics of circular motion, and motion of a vehicle on a level circular route, centripetal force, centrifugal force, applications of centrifugal force. These are the topics, but these topics, it's a right time to explain in the teaching learning activity at the time of after reopening the schools. Okay, now we will start the new chapter, work, energy, and power. See, work is one of the physical quantity. Energy is also one of the physical quantity. Power is also one of the physical quantity. Work, energy, power, these three are the physical quantity. This chapter deals the important learning of work, energy, and power. First of all, we are going to see briefly about work. The term work is used in our daily life. See, students, can you hear my voice? If my voice is audible or not?
Yes,
Yes, sir. Audible, sir.
Okay.
Yes, sir.
We use the word work each and every in our daily life activity. We use the term work. Okay. It refers to be both physical work as well as mental work. But in general activity, the term work is very, very important thing. But in physics, the term work it is a precious definition. It possesses a precious definition. And also, when we do the work, how we perfectly define the work. See, students, when we do the work, but in our daily life, we use the term work. Physical work as well as mental work. But in physics, the term work refers to be one of the physical quantity. The physics treats as work is one of the physical quantity, and also it possesses a precious definition. How we define the work? Without force, we cannot speak about work. You understand, the students? In the absence of force, we cannot talking about work. We cannot speak about work. So, it is one of the objects. You observe the students, it is an object. If external force acting on the object, then the object displaces along the direction of applications of force. Here, S vector is the displacement. See, very simple. Let me assume one object. That object is acted upon by an external force, F vector, but that body displaces along the direction of force. S vector is a displacement vector. Then, how we measure the work done by the work done by the force, when force is acting on your body, body displaces along the direction of applications of force, then work is said to be done by a force. It is the exact definition of force. Okay, students. Work done by a force. Work is said to be done by the force when the force is applied on the object.
Sir, your voice is not audible, sir.
Okay, I will rectify it. Right. Now you are able to hear my voice?
Yes, sir.
Okay. Now we define the work done by a force. Without the force, we cannot speak about work. Okay, in the absence of force, we cannot speak or we cannot discuss about work. So, work is said to be done by a force. When the force is acting on an object displaces along the direction of motion of the object. Then work is said to be done by a force is there. That is the exact definition of force. Okay. Then work is said to be done by a force. Dear students, tell me, work is said to be done by a force. When a force is acting on an object displaces along the direction of force. Don't forget, keep it in your mind. Object displaces along the direction of force, then only work is said to be done by a force. Okay. Clear or not? Okay.
No, sir. One time say, sir. So one time recall the force.
Horizontal surface. Let me consider one object. That object is placed on the horizontal surface. Mass of an object M. Initially at rest position. Now we apply the force acting on the object. Now the external force acting on the object along this direction, F vector. Due to this force, body displaces with that small displacement along this direction. dr vector. Dr refers to be due to the applications of force, body displaces along the horizontal direction with the small displacement dr. Now, dr vector makes the theta angle with this direction of force, or theta is the angle between direction of applications of force and the direction of displacement. I am talking about when a body of mass is placed on a horizontal surface. Initially, we notice that initially at rest position, when we apply the external force acting on the object along this direction, body displaces with the small displacement dr, small displacement. Small displacement dr along the horizontal direction. But theta is the angle between direction of force and the direction of a small displacement. Then work is said to be done by the applications of force. How we measure? Already we know the definition of work. Work is said to be done by the force. Okay, work is said to be done by the force if the body moves along the direction of applications of force, then only work is said to be done by the force. But here, direction of applications of force and the direction of small displacement makes the theta angle with each other. How we measure the work done by the force? See, in vector, force vector makes the theta angle with this horizontal dr vector. Then the force vector is essential to resolving into two components. One is horizontal component, another one is vertical component. See, horizontal component of force. This is horizontal component of force. It is vertical component of force because one of the vector makes the theta angle with this horizontal. It is essential to resolving into two component. One is horizontal component, another one is vertical component. Force vector makes the theta angle with this dr. Then the horizontal component is F cos theta. F cos theta. In the resolution of vector. Vertical component is F sin theta. Okay, that force vector is essential to resolving into two component. Why we resolving into two component? Because what is said to be done by applications of force, when a force is acting on your body, body displaces along the direction of motion. Then only what is said to be done by a force. But here, force and the displacement with dr vector makes the theta angle with each other. We are going to measuring the work done by the applications of force. Then only it is essential to resolving into two component, F cos theta component and F sin theta component. F sin theta component does not contribute the work because that F sin theta component, that component of force which is perpendicular to the direction of displacement. That's why that F sin theta component of force does not contribute to the work. You understand the students? Hello?
Yes, sir.
Can you able to hear in my voice?
Yes, sir.
Yes, sir.
Sir. Yes, sir.
Very important concept you observe clearly. Common definition of work is said to be done by a force. When a force is acting on your body, body displaces along the direction of applications of force. But here, the force is acting along this direction, but the body displaces with the dr small displacement along the horizontal direction. Then how we measure the work done by the force? That's why that force vector is essential to resolving into two components by the resolution of vectors. Horizontal component F cos theta, vertical component of force is F sin theta. F sin theta, vertical component of force does not contribute to work. But cos theta, F cos theta component, this component of force is acting along the direction of displacement. So F cos theta component of force contributes the work done by the force. So generally, that work done by the applications of force can be expressed in mathematically work done by the force dW, because due to applications of force, body displaces with the small displacement dr. Then work done by the applications of force is dW is equal to commonly F vector dot dr vector. See, work done by the force dW is equal to F vector dot dr vector. But in the definition, work done by the force dW is equal to the product of force and displacement. Here, component of force along the direction of displacement multiply with displacement. See, that is the definition of force. Work done by a force or small amount of work done by a force can be measured. You take the product of component of force, that is the component of force along the direction of displacement and displacement, multiply with the displacement, we get a small amount of work done by the force. It can be right mathematically, dW is equal to component of force along the direction of displacement. Tell me, any one of you. There are two component of force. One is F cos theta, another one is F sin theta.
Sin theta.
Sin theta. Sin theta.
No, ma.
Cos
You
theta.
want to measure
F cos
in the
theta.
F cos theta.
S cos theta.
You observe,
Horizontal component.
you observe that.
Horizontal direction, that we will use F cos theta, sir.
Okay, we measuring the work done by the force. You take the product, you see the component of force along the direction of displacement. See, the direction of displacement is dr. Component of force is along the direction of displacement is F cos theta.
F cos
F.
theta.
F cos theta.
Multiply with displacement is dr.
dr.
Displacement is dr.
Yeah.
So in this way, we can measure the work done by the force. So dW is equal to F into dr cos theta. Okay.
Yes, sir.
Here, dW is the small amount of work done by the applications of force. Then F is the constant force acting on your body. dr is the small displacement produced in your body due to constant force. Theta is the angle between direction of force and the direction of displacement.
ஷார்ட்கட் வேலை செய்யறடா ரெண்டு மூணு கீ.
F is the force. dr is the small displacement. Theta is the angle between direction of force and direction of displacement. Okay. Then we want to calculate the total amount of work done by applications of force. You see the students, the same horizontal surface. If an object is placed on the horizontal surface, mass of an object at m, we apply the constant force acting on your body, F vector. Due to the constant force, body displaces with the displacement R vector. If theta is the angle between direction of application of force and the direction of displacement, then calculate the total amount of work done by the force. Here, total amount of work done by the applications of force, W is equal to F vector dot R vector. Okay, remove the vector notation. Total amount of work done by the force, W is equal to component of force along the direction of displacement. You see the students, component of force along the direction of displacement, F cos theta. Yes, students, in my voice is audible or not?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
The force is resolving into two components. One is F cos theta.
F cos theta.
Cos theta, F sin theta.
Second component is F sin theta.
sin theta.
Okay, F sin theta component of force does not contribute to work because it is perpendicular to the direction of displacement. But the F cos theta component of force contributes the work because which is acting along the direction of displacement. So work is done by a force is measured. Take the product of component of force along the direction of displacement and displacement. So F cos theta into R. It is the expression to represent total amount of work done by the constant force acting on your body. I wrote two equations. work done by the small amount of work done by the constant force and the total amount of work done by the constant force. Total work done by the force. What is the difference between these two? Small amount of work done and the total amount of work done. What is the difference of these two equations? You see the two equations, but both the case, magnitude of force acting on your body remains constant. But in first equation, due to the applications of force, body displaces with the small displacement dr. Then small amount of work done by a constant force acting on your body is F cos theta into dr. But constant force acting on your body displaces with then displacement R, then total amount of work done by the force is W is equal to F cos theta into R. Okay. What is the difference between these two? Hey, students, what is the difference between these two equations? You feel any difference? Are both
Yes, sir.
equations similar? Tell me, any one of you. Both the equation is a similar equation or difference is there?
Small work done, total work done.
That's all. Small work done, total work done. How
Total
do you
work done.
differentiate these two? Hello?
Yes, sir.
So there is change in
How do
Sir.
you differentiate these two equations? How do you distinguish? How do you distinguish these two equations? Very simple thing. Both the equation F cos theta, F cos theta, component of force along the direction of displacement, it will not change. But only the difference in first equation, due to the constant force, body displaces with the small displacement dr. Second case, body displaces with the total displacement r. That is the only difference. Okay. Then see, work done by the applications of force, generally we can express mathematically W is equal to F vector dot R vector or dW is equal to F vector dot dr vector in vector notation. See, force is a vector quantity. Force is the vector quantity. Displacement is also vector quantity. Vector quantity. If take the dot product of these two vectors, resultant is a scalar quantity. Work done is a scalar quantity.
Scalar quantity.
That's all. So, scalar product of two vector, resultant is a scalar. Okay. Or dot product of two vectors is a dot product. Dot product of two vectors. Force is one of the vector quantity, displacement is one of the vector quantity. You take the dot product of these two vectors, resultant is a scalar quantity. Why? Work done is a scalar quantity. Okay. We remove the vector notation work done by a force. Work done by a force W is equal to F cos theta into R. Or in other words, W is equal to F cos theta into dr. Okay. So now we go to see the SI unit of work done or SI unit of work. Unit of work. So work done formula W is equal to F cos theta R or work done by the applications of force W is equal to F for cos theta. Sometimes it can be expressed Fs cos theta. Here S refers to be displacement produced in a body. Displacement produced in a body. Depending upon the situation, R refers to be displacement produced in a body due to applications of constant force, or S also refers to be displacement produced in a body due to applications of constant force. Now we go to see how we put the unit of force. Unit of work. We want to derive the unit of work. Unit of work is joule. SI unit of work is joule. Okay. Equivalent unit of joule. You see, W is equal to F for cos theta. W force, unit of force is Newton, unit of displacement meter. Okay. Cos theta, theta value substitute, maybe theta value 10 degree, 20 degree, or 30 degree, whatever it may be. Cos of any angle, it will give that numerical value. Okay. Cos 60 degree. What is the value of cos 60 degree? Maybe angle between direction of force and the direction of displacement is 60. We substitute cos 60. What is the value of cos 60? Hello?
So 1 by 2.
1 by 2. 1 by 2.
1 by 2.
1 by 2.
1 by 2. 1 by 2 is equal to 0.5. 1 by 2 is equal to 0.5.
Yes, sir.
Yes, sir.
0.5. Just a numerical number. That number possesses any unit?
No, sir. No, sir.
The number does not possess any unit. So that's
Yes,
why
sir.
I left cos theta. SI unit of force, SI unit of work is joule. Okay, which is equivalent to Newton meter, which is equivalent to Newton meter. Okay.
Yes, sir.
And one more unit is there for work. W is equal to force, formula ma, mass into acceleration, displacement R. Then unit of mass is kg, unit of acceleration meter second power minus 2, unit of displacement meter.
Meter.
Kg, meter square second power minus 2. It is also one of the unit of work. So SI unit of work is joule, equivalent unit of work is Newton meter, kg, meter square second power minus 2. Then dimensional formula for work. Okay. Then we go to attain the dimensional formula for work. How we attain the dimensional formula for work? Already we derived the unit of work. Joule, which is equivalent to Newton meter. It is also equal to kg, meter square second power minus 2. What is the dimension of kg? M. Dimension of meter. L square.
L square.
L square.
Dimension of second. T power
Is
minus 2.
Minus
Dimensional formula for work. Dimensional formula for work.
Work.
So we completed what is work, how we define the work. Okay, then unit of work, then I completed dimensional formula for work. Now we go to see when is work is done by a force is maximum, when is work is done by a force is 0, when is work is done by a force is positive, when is work is done by a force is negative. This information. Okay. You see the students. Let us consider one horizontal surface. One object of mass is placed on its horizontal surface M. Okay. Now we apply the force acting along the direction on the object. Due to the applied force, body displaces along the direction of force or vector. You see, here in this case, when external force is acting on the object, see the direction of motion of the object is along the direction of force. You see, along the direction of displacement of direction of displacement is the same direction of force or not?
Yes, sir.
Okay. Then how we measure the work done by the force acting on your body?
Work done is equal to force multiplied.
Yes, tell me. W is equal to F cos theta R. That is a common equation.
Yes, sir.
Total work done by the force. Because due to applications of force, the body displaces with the displacement R. So therefore, total work done by the force W is equal to F cos theta into R. So W is equal to F R cos theta. Okay.
Yes, sir.
We want to measuring the work done by the force or total work done by the applications of force. We know the magnitude of force. We know the magnitude of displacement. We know the angle between direction of force and the direction of displacement. See, force is there. Due to the applications of force, body displaces with the displacement R. What is the angle between direction of force and the direction of displacement in first case? You see the students, what is the angle between direction of force and the direction of displacement? The direction of force along this direction, due to the applications of force, the body displaces with the displacement R. So both is acting along the same direction.
Yes, sir.
Then what
Yes,
happens
sir.
angle between these two?
0 degree.
0 degree. If direction of force and the direction of displacement acting along the same direction, angle between these two, theta is equal to 0 degree.
0 degree.
Okay. Then what done by the applications of force? W is equal to F R cos 0 degree. Cos 0 degree value. Hello students. What is the value of cos 0 degree?
0.
1.
Don't forget cos 0 degree. 1. Total work done by the constant force acting on your body, F or cos 0 degree value 1. Then total work done by the constant force acting on your body, W is equal to F into R.
FR.
into R. This is the maximum work is done by applications of constant force. See, maximum work done by the applications of force. Direction of displacement of your body is the same direction of force. Don't forget, keep it in your mind. Maximum work is done by a force when force acting on your body displaces along the direction of motion. No, body displaces along the direction of a motion, or body displaces along the direction of force, then what is said to be done by a force is maximum. Okay, this is the maximum work done by the force, F4. Okay,
Yes, sir.
Yes, sir.
so hereafter, then what is done by a force is maximum. I apply the force, okay. Then what is done by maximum? The condition is body displaces along the direction of applications of force. Here, applications of force and displacement acting along the same direction. Then theta is equal to 0 degree. Then what is done by a constant force acting on your body is maximum F4. Then in second case, take one horizontal surface. The same object is placed on the horizontal surface. That object of mass M. See, We apply the external force acting on your body along this direction. We apply the force acting on your body along this direction like vertical. Due to that force, body displaces with the displacement or vector in horizontal direction. Then what happens? Work done by applications of force. I take one body is placed on the smooth horizontal surface. We apply the force acting on your body along the vertical direction. Due to that applied force, body displaces in horizontal direction. In that situation, how we measure the work done by the applications of force? With the help of equation. Yes, with the help of equation. That one equation is there. That equation is used to measuring the work done by the applications of force. W is equal to
FR.
F or cos theta. F or cos theta. Here force is there, displacement is there. But what happens? Angle between direction of force and direction of displacement.
90 degree.
90 degree. See the direction of force and the direction of displacement like this. Angle between these two, 90 degree. Substitute work done by the force W is equal to F or cos 90 degree. Cos 90 degree value 0.
Zero. A is
Yep.
equal to
Or cos 90 degree value 0. Then
zero.
work done by the applications of force.
Zero.
Zero.
Okay, you understand this concept?
Yes, sir.
In the second case, when work done by the force is 0. When work done by the force is 0. In the options of force, we cannot talking about work. But here, force is there. Force is acting on your body. Body displaces along the horizontal direction. Angle between direction of applications of force and the direction of displacement is 90 degree. But what happens? Work done by the applied force on your body? 0. So hereafter, when force and direction of force and the direction of displacement acts together, work done by the applications of force is 0. We'll see one example. Hello, dear students. We'll see one example. Same thing. It is one of the horizontal surface, horizontal smooth surface. Let me assume one object. The object of mass m. That object of mass m is placed on the smooth horizontal surface. I notice that object of mass m is moves on a smooth surface with a constant velocity on the smooth horizontal surface. Gravitational force acting on your body vertically downward direction. You see, gravitational force. Each and every object experiences gravitational force. This mass of an object is experiences gravitational force. Gravitational force acting on your body is vertically downward direction. But the body moves on its smooth horizontal surface along this direction with the displacement R. What happens? Work done by the gravitational force in this situation or in this case?
Minus 90 degree.
You see, ma, actually, we noticed at that moment, object displaces along the horizontal direction with the displacement R vector. But that object experiences gravitational force is vertically downward direction. The gravitational force. What is the value of work done by the gravitational force? Work done by the gravitational force. See, commonly, work done by the gravitational force is equal to formula F or cos theta. Yes, students. How we calculate or how we measure the work done by the force? General equation, mathematically, F or cos theta.
Yes, sir.
Okay, here work done by the gravitational force is equal to, we know that gravitational force Fg. Body displaces with the displacement R. Then what happens? Angle between direction of gravitational force and the direction of displacement?
Equal.
90 degree.
90 degree, not equal, mark. See, direction of gravitational force vertically downward, but object displaces on the smooth horizontal surface or along the horizontal direction. Angle between direction of gravitational force and the direction of displacement is 90 degree.
90 degree.
Then
0. Work done is 0.
work done is 0.
Work done is 0.
Then is 0.
Cos 90 degree. Cos 90 value 0.
0.
Work done by the gravitational force.
Work done by the gravitational force equal to 0.
Okay. Why here work done by the gravitational force is 0?
Because the angle
We
is
know
Because the angle is
object displaces on the smooth horizontal surface along the horizontal direction, along this direction. But that object experiences gravitational force is vertically downward direction. Angle between direction of displacement and the direction of gravitational force is right angle. Then work done by the gravitational force is 0 too. Okay.
Yes, sir.
We completed. Then work done by the force is maximum. Then work done by the force is 0. Okay. Work done by the force is maximum means body displaces in along the direction of force. Work done by the force is maximum. When work done by the force is 0. If body displaces right under to the direction of applications of force, work done by the force is 0 too. Then we go to see when work is done by a force is negative or minimum. Okay. See, in first case, work done by a force, if the body displaces along the direction of applications of force, work done by the force is maximum. But that work done by the force is positive or negative?
Positive.
Positive, because work done by a force is maximum is equal to F4. That is a positive value. Okay. Next, in third case, I take the same smooth horizontal surface. The same object is placed on the smooth horizontal surface. Object of mass M. Okay. I apply the force along this direction, but the body displaces in opposite direction with the displacement r vector. Okay. Dear students, my voice is audible or not?
Yes,
Yes,
sir.
sir. Audible.
Third case, the same situation when object of mass is placed on the smooth horizontal surface, I apply the external force or I apply the force acting on your body towards right, but the body displaces in opposite direction,
Left side.
left side. Okay.
Yes, sir.
Then what is the work done by a constant force acting on your body? Here force is acting on your body. How we measure the work done by a constant force acting on your body? By using expression
W is equal to F for cos
W is equal to F
F for
or
cos theta.
F for cos theta.
theta.
Okay, good. Then here force is there, displacement is there. What is the angle between direction of force and the direction of
180
displacement?
degree. 180 degree. 180 degree.
Okay. Theta is equal to 180.
180 degree.
W is equal to
180.
F or
180.
cos 180 degree. Cos 180 degree.
180
Cos
degree.
minus 1.
Minus 1. Minus
Okay. Then work done by the
Minus
force,
1.
W is equal to
Yeah,
minus F R. Minus
F
F
for.
R. See, students, in this case also, work done by the force is maximum magnitude F R, but it is a negative. But it is a negative work done. So maximum work is done by a force, but the maximum work done by a force, but it is negative. Okay. When work is done by a force is maximum, but the same work that is negative. If direction of force and the direction of displacement acting in opposite direction, work done by a force is maximum, but it is a negative work done. Negative work done. Okay. It will be proved with one example. Are you ready to hear the concept?
Yes, sir.
Yes, sir.
In practical situation, it is the surface of the earth. It is the surface of the earth surface. Throw one ball vertically upward direction. Okay, I throw the ball vertically upward direction like this. Okay. After that, the ball experiences gravitational force vertically downward direction. Vertically downward direction. But the ball displaces vertically upward direction with the displacement r vector. You see the situation. We stand on the surface of the earth. We throw a ball vertically upward direction. After that, you see the motion of the ball, either downward direction or upward direction.
Downward direction.
How?
Downward direction.
Throw the ball vertically upward direction. The ball is moved downward. It is possible. I am not talking about freely falling ball. We throw the ball from the surface of the earth. You see the direction of motion of the ball. It will move vertically upward or downward.
Upward
Direction.
Upward direction.
Upward direction.
Okay. Vertically upward.
Vertically upward.
Okay. It will reach as a maximum height at any one moment. But during its motion, you observe that the ball moves vertically upward. Okay.
Yes,
But
sir.
the ball experiences gravitational force vertically downward.
Yes, sir.
Yes,
Vertically
sir. Downward, sir.
downward.
Downward.
What is the work done by the gravitational force? It is the best example. It is the negative work done. If you throw the one ball vertically upward direction, direction of motion of the ball is vertically upward, but the ball experiences gravitational force is vertically downward.
Sir.
What is the work done by the gravitational force? W is equal to
Equal to F of
W equal to
FR.
F4 cos theta.
Theta.
F means gravitational force.
Yes,
R
sir.
is displacement. F, G,
G.
Fg or
and cos theta is the angle between direction of gravitational force and the direction of displacement. Both is acting in opposite direction.
180 degree.
yes, sir, 180 degree.
These two theta is equal to 180 degree. Cos 180 degree minus 1. Work done by the gravitational Fg into R cos 180 minus 1. So work done by the gravitational force is maximum. But,
ஆமா தள்ள போனது போ
Negative.
okay.
நல்லா அப்புறம் சாப்பிடுங்க போ
Kedarivalan, why you raise the hand? If you have any doubt?
போ
Hello, Kedarivalan.
எஸ் சார்
You have any doubt?
நோ சார்
Sima, I give one example. When is
Okay.
work done by a force is negative? When object or any stone or any ball is thrown vertically upward direction. After throwing, see the direction of displacement of your ball vertically upward direction, but the ball experiences gravitational forces vertically downward direction.
Downward direction.
How do you measure the work done by a gravitational force acting on your ball? That work done by a gravitational force is maximum, but that work done by a gravitational force is negative. Okay.
Yes, sir.
Yes,
The
sir.
complete-
Sir, can't hear your voice clearly, sir.
Students, we completed when is work is done by a force is maximum. When is work is done by a force is 0. When is work is done by a force is negative. Okay.
Sir.
Then we go to see another one important point related to work done by a force acting on your body.
Thank you, sir.
Okay. This
Okay,
is one of the arguments of it.
Thank you, sir.
Mass is placed
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
no, wait, I will few concepts related to work done by a force. What are the vectors depends upon work done by a force?
Thank you, sir.
சொல்றாங்களே. Thank you, sir.
Thank you, sir.
Thank you, sir.
Yet I not completed. You wait few seconds.
Bye, sir.
Yes, sir.
Okay, sir.
Yes, sir.
Force acting on your body.
Okay,
Look at that force, body displaces along this direction, like S or R vector, S vector or R vector, angle between these two theta, work done by the applications of force, W is equal to F R cos theta,
F or cos theta.
F S cos theta. Okay.
Yes, sir.
What are the vectors depends work done by a force? First factor, magnitude of force. Second factor, displacement. Magnitude of displacement. Third factor,
Gravitation.
the angle between direction of displacement and the direction of force.
Theta.
So one of the important 2 mark questions, what are the factors depends upon work done by a constant force? One is magnitude of force, magnitude of displacement, and angle between direction of force and the direction of displacement. See, if displacement is there, force is 0. What happens work done by the force?
0.
What happened? W
0, sir.
W
F
is
or cos theta.
for cos theta.
Displacement is there.
Yes, sir.
In the absence of force, what happens work done by the force is 0.
Zero.
Because there is no force
Force
acting
is
on your body.
absent.
There is no
Another one,
Force is absent.
force is
absent.
there is no force acting on your body, then immediately work done by the force is 0. Okay.
Zero.
We apply the force, but body does not displaces. F for cos theta. We apply the force, but displacement is 0. What happens work done by the force?
Zero.
0.
Zero, sir.
Okay, good.
0.
Okay. In third situation, force is there, direction of displacement is there, then work done by the force is 0. When
Cos theta is equal to 0.
cos theta is equal to 0.
0.
Equal to F for cos theta. Here cos theta is 0. When
F for W is equal to 0.
W is
90 degree.
W.
cos theta value 0. Work done by
Theta is equal to 90 degrees.
this situation, work done by force is 0. In the absence of force, displacement is there. In the absence of force, work done by the force is 0. But in the presence of force, but the body does not displaces, work done by the force is 0. The force and the displacement is there, but the direction of force and the direction of displacement acts like displacement also work done by the force is 0. Okay, students.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Go to the topic. What is work? S unit of work, dimensional formula for work. How we properly express the work done by a force in the expression wise. Then, what are the factors for work done by the force? You go through all information in your textbook. Take
Yes,
proper
sir.
notes. Helpful to you.
Yes, sir.
Thank you, students. Thank
Thank
you.
you.
Madam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Unmuted.